In this video, we'll show a programmed arm in action, followed by some tips on how macros are used in the programming. First, in sped up video, the arm runs through its program for a quick view of the action. Here's the same program at normal speed. The arm first tightens a large screw into a nut. The arm picks up the red ball from the T on the right, and while holding the ball, the arm folds itself under just to show it can. The arm then deposits the red ball on the T it left. After a bit of intermediate motion, the arm picks the ball up again and returns it to its original position on the right T. The arm then loosens the large screw. Notice that the whole body of the robot shudders slightly during the turning operation. This is a result of misalignment between gripper and screw. Notice also that this same misalignment causes rubbing between one of the fingers on the gripper and the screw, producing undesired turning. And finally, not shown here, you may have spotted that the picking and placing of the ball on the tees is a bit sloppy at some points. Eliminate all of these alignment flaws for a more impressive and elegant presentation. We now repeat the program, recording it from overhead so we can see how links 1 and 2 move during program execution. Macros are used to organize and clarify a script, making the script easier to read and to write. You define a macro by starting with the word macro, followed by your name for the macro. Then you add one or more commands, which may be either move commands or the names of other macros, and then the word end. That's it. For clarity, we'll block out a couple of script lines that are not pertinent to what we're doing now. Look at the definition of the macro grip screw. Grip screw contains just one command, but we really want to create a macro since we'll be using grip screw more than once in this script. Note the value -1208 for the move of servo 6 in grip screw. This value was gotten by using teach mode. We put the screw between the open fingers of the gripper. Then, still in teach mode, we moved servo 6 to squeeze and loosen the fingers on the screw. We were seeking a position that had the dancing ABSI or ABSI value for servo 6 centered around 200 to 250. ABSI is just a name we made up. It is not used in science or in engineering or anywhere else as far as we know. ABSI and other servo values and properties are shown in the gray Servo Properties pane below the blue scripting area. Find ABSI now. Got it? Okay. And by the way, ABSI stands for the absolute value of the servo current. Current is usually denoted by the letter I, so ABS-I or just ABSI. In our case, ABSI generally corresponds to the torque or rotational force the servo is exerting. Okay, back on task. We were tuning the position of the grip screw macro. In general, the idea is to find a position where the screw is gripped snugly enough for the demo. You can pull the screw gently to test how well it's held. When we used this procedure, we got a position of minus 1208 for a good grip on the screw. In your own robots, this high enough ABSI value will of course vary by application. That is, you can increase the motor torque to what you need, but an ABSI value over about 600 can eventually overheat the motor. A few minutes with ABSI at a high value may cause the motor to shudder, then fail completely. All right, the definition of the macro grip screw is becoming clearer. We understand that we can use the word grip screw in place of the command that is inside the grip screw macro. Put another way, when the script is run and the word grip screw is reached, the single command move 6 to minus 1208 will execute. The next macro, grip release, sends servo 6 to its minimum position for widest finger opening. And finally are the macros twist CC for counterclockwise, which loosens the screw, and twist CW, which tightens it. Here are 3 executions of twist CC. Watch for the macros it uses. We'll count them off. Grip release, jump servo 5, the wrist, to min pause, wait 0.3 seconds. Grip screw, jump 5 to max pause, wait 0.3 seconds. Grip release. And now twice more at normal speed. Here we highlight the differences between the twist CC and twist CW macros. The only change is the reversed order of the jumps for servo 5, the wrist. Take a few moments to compare the macro definitions. Okay, it's time to wrap up, and here are the 3 lessons about macros to take with you. Macro usage becomes clearer with just a little practice. For readability, use macros to name motions. Putting names on motions helps document what the parts of your script are supposed to do. When the same motions are used in more than one place, as with the definitions of twist CC and twist CW, macros should be considered.